Welcome. Today we will finally answer some questions we had about events happening in infinity. Last time we established that the probability of infinitely many events in a series happening is the same as the probability that for each big number n there will be a bigger number k such that event ek happens. Okay. So how can we estimate this probability? We know that it will be lower bounded by 0. No surprise here. How about the upper bound? Probability that it will happen for all n, it's smaller than it will happen just for a particular n. Also, the probability of the sum of events is less or equal to sum of probabilities of events. Why not just equal? Because these events can happen together. In other words, there might be a non-empty intersection which we don't want to count twice. The series of numbers is an upper bound for our probability. What really matters is what happens if we increase our cutoff point n to infinity. So let's look at this expression as n goes to infinity. So here we just have an infinite series of numbers, or to be precise, an end tail of such series, starting from point n. The limit of this tail can just take two values. If the series is divergent, this will be infinity, which is not a useful upper bound. However, if the series is convergent, this tail will go to 0. And this is more promising. This is the condition for convergence of the series. And the fact that the tail of the series goes to 0 as n goes to infinity is both necessary and sufficient condition for convergence of the series. This result will enable us to use so-called squeeze theorem, which my mathematics teacher called Policeman Theorem. The reasoning goes like this. If you have two policemen on your left side and on your right side, and both policemen are going to police station, that means you are also going to the police station. So, in mathematics, if you have two sequences, both of them going to the same limit, everything that is in between also has to go to this limit. So, if the series is convergent, this sequence goes to 0. This sequence obviously goes to 0. It's already there. So that means that these two sequences also have go to 0 as n goes to infinity. But in fact, this is just a number because it does not depend on n. So that means it must be 0 all the way. So, if the probability series is convergent, then the probability of getting infinitely many events ek is 0. This result is called Borel Cantelli lemma. What are the consequences of this result? Well, there are not too many things in real life that are infinite, but cosmos is a pretty good proxy. Think about the probability of intelligent life emerging on a given planet. This event is like a success in a Bernoulli trial, where the probability is very small. But there are and there will be so many planets in the universe that we can think of it as an infinite series in Bernoulli trials. What if, as the time passes and the universe expands, the probability of intelligent life decreases? What if it decreases so fast that the probability series is convergent? According to Borel Cantelli lemma, that would mean that the probability of intelligent life emerging in the future will be zero. Or, in other words, life will simply stop occurring. Maybe that would explain why we have not made any contact to an extraterrestrial civilization so far. Maybe we are one of the last successes in a series of Bernoulli trials. Maybe we should be more responsible to what we do to our planet. Let's leave the calculation of probability of life on to the astrobiologists and do a quick recap of the Borel Cantelli lemma. This is what it says. If we have a series of events whose probability series is convergent, the probability of these events happening forever is zero. Here are the major concepts we use to prove it. Events happening forever means that no matter how far we look, there will always be a bigger number for which the event happens. Secondly, series is convergent if and only if its tail goes to zero as n goes to infinity. If you think about it, it's a very similar notion to this one. Finally, if two sequences converge to the same number, the sequence which is between them also converges to that number. Okay, so we know what happens if the series of probabilities is convergent. But what if it is divergent? We will learn about it in the next episode, the second part of Borel Cantelli lemma. I know there is a lot of stuff going on in this episode. You might want to watch it a couple of times to get a good grasp of it. I'm curious, what do you think about the life in the universe and the episodes in general, so feel free to share your thoughts in the comments. I hope you enjoyed that, and we will see each other in the next episode.